All right, you guys, in this section, we're going to be graphing rational functions, okay? So let's go over the steps of how to graph a rational function first, and then we're going to do a bunch of examples until you guys get the hang of it, okay? So anytime you are analyzing the graph of a rational function, so that means they're going to ask you a bunch of different things. They're going to have you graph it. They're going to have you find intercepts, have you find the asymptotes. They want to know where it's increasing or decreasing. Okay, so we're always going to follow these steps. So step 1 says to factor the numerator and the denominator of r, which is your function. Find the domain of that rational function. Okay. Then step 2, you're going to write r in lowest terms. Remember, lowest terms means you have no common factors in the numerator and the denominator. You've completely factored everything and gotten rid of the common terms. Step 3 says you're going to find and plot the intercepts of the graph. Remember, we have 2 types of intercepts. We have x-intercepts and we also have y-intercepts. Then we're going to use the multiplicity to determine the behavior of the graph of r at each x-intercept. Then step 4, we're going to find the vertical asymptotes, okay? Remember, you find the vertical asymptotes by setting the denominator equal to 0, okay? Then we're going to graph each vertical asymptote using a dashed line, and we're going to determine the behavior of the graph at r on either side of each vertical asymptote. Step 5, we're going to find the horizontal or oblique asymptote if one exists, and then we're going to find the points, if any, at which the graph of r intersects this asymptote, And then we're going to graph the asymptote using a dashed line. We're going to plot any points at which the graph of r intersects the asymptote. In step 6, we're going to use the zeros of the numerator and the denominator of r to divide the x-axis into intervals. We're going to determine where the graph of r is above or below the x-axis by choosing a number in each interval and evaluating r there. And then we're going to plot the points found. And then step 7, we're going to use the results obtained in steps 1 through 6 to graph r. Okay, so I know those steps, they seem like a lot. It's only a lot because you guys haven't done it before, but I promise it'll get easier as we work through the problems. Okay, so I thought the best way to show you this section was to kind of go through some of your homework problems that I've assigned, all right, and kind of walk you guys through those step by step. Okay, if you guys need more examples, remember I do have more included in my PowerPoint slides that you guys have, all right, but I want to work through your homework with you so you can get a better feel for the problems I'll be asking you. Okay. All right, so for this first problem, it says find the intercepts of the graph of the equation y equals x squared minus 25 over x squared minus 4. And it says select the correct choice below, and if necessary, fill in the answer box to complete your choice, okay? So remember, we have 2 types of intercepts, okay? We have x-intercepts, oops. All right, we have x-intercepts. All right, and we also have y-intercepts. Okay, if you guys remember, we find x-intercepts by setting y equal to 0. And solving, we find y-intercepts by setting x equal to 0 and solving. Okay, all right, so I'm going to do that first. Okay, so let's rewrite our problem. So we have, make this smaller, y equals x squared minus 25 over x squared minus 4, okay? Now, let me show you something. So our step said, right? Step 2 was to put our function in lowest terms, and then step 3 was to find the intercepts. So before you find the intercepts of your function, you need to make sure that your function is in lowest terms, which means that we've completely factored anything and we've gotten rid of any common terms. So if I'm looking at this numerator here, x squared minus 25, that's difference of 2 squares. So when I go to factor that, I get x minus 5, x plus 5. In the denominator, that's still difference of 2 squares. That's x minus 2, x plus 2, okay? So at this point, I look at my function to see if I have any common factors in the numerator and the denominator. I don't, so this is in lowest terms, so I'm good. So now I can go ahead and find the intercepts. So the order in which you find the intercepts doesn't matter. Remember, it's up to you. I just naturally find the x-intercepts first, but doesn't matter. All right, so I'm going to look for the x-intercepts, which means that I'm going to set y equal to 0. So in this function, I'm going to say 0 equals x minus 5, x plus 5, all over x minus 2, x plus 2. Okay. Now I can make this a proportion. I can write 0 over 1 and cross multiply. So it's going to give me 0 times the denominator, which is going to be 0, and 1 times the numerator, which is x minus 5, x plus 5. All right, each of those terms are already factored, so I can go ahead and set them each equal to 0. So x minus 5 equals 0, x plus 5 equals 0, and then solve for x. So here I'm going to add 5, so x equals 5. This one I'm going to subtract 5, x equals negative 5. So they want me to write these as ordered pairs, all right? So x-intercepts are always in the form x comma 0. All right, so whatever value I got for x goes in the first position, and then 0 goes in the second. So I'm going to write these as 5 comma 0 and negative 5, 0. Okay, so those are my two x-intercepts. All right, now let's go to find our y-intercepts. So let me change my color. All right, so to find y-intercepts, remember you're going to set x equal to 0. Okay. All right, so in this function, everywhere that I see an x, I'm going to make it 0. So that's 0 minus 5, 0 plus 5, 0 minus 2, 0 plus 2. All right, so in the numerator, 0 minus 5, that's negative 5. 0 plus 5, that's positive 5. In the denominator, 0 minus 2, that's negative 2. And 0 plus 2, that's positive 2. So I'm going to multiply that together. So in the numerator, negative 5 plus times positive 5 is negative 25. All right, and in the denominator, negative 2 times positive 2 is negative 4. All right, when you divide these, anytime you divide a negative by a negative, that's positive. So 25 over 4. And I would see if it reduces. It doesn't. So that's my y-intercept. So y-intercepts, remember, you write them in the form 0 comma y. Okay, so this answer would be 0 comma 25 over 4. Okay, so you just found your x and y-intercepts. So for this particular problem, you would select the first answer, and then you would list your ordered pair as such. All right, cool.